And this week we will talk about BVRAAMs, that is Beyond Visual Range Air-to-Air Missiles. Now, air-to-air missiles are an integral part of aerial warfare, providing a credible option to target and intercept enemy missiles and aircrafts. Now, BVRAAMs, or Beyond Visual Range Air-to-Air Missiles, are designed to engage targets at a range of more than 30 kilometers. India has recently developed its first indigenous BVRAAM called Astra, which is expected to be inducted soon into Indian Air Force. Now, with a speed of Mach 4.5, the Astra has a maximum range of 110 kilometers when fired from an altitude of 15,000 meters. India has also asked France to equip the first 4 Rafale jets with Meteor missiles, which are active radar-guided BVRAAMs, offering a multi-shot capability against long-range maneuvering targets. So how has the BVRAAM technology evolved over the years, and how useful and effective are these missiles in air-to-air combat missions? For more on this, we're joined by a distinguished panel of guests today in the studio. Let me first introduce the guests to you, beginning with retired Lieutenant General Dr. V.K. Saxena with me here, distinguished fellow from VIF. We also have with us retired AVM P.K. Srivastava, our defense expert, and Manu Pabi, senior editor, Economic Times, somebody who keeps a tab on the developments in the defense sector out here. Let me begin with you, General Srivastava, and let's try and understand the concept of BVRAAMs and how from air-to-air missiles we have reached this particular stage.
Okay. In a air-to-air combat or in aerial combat, between 2 opponents, the one who detects his opponents first, the one who lays on his target first, the one who shoots his missile first, and the one who shoots his missile keeping himself away or at the safe distance from the enemy's munition survives to fight another day. This is the basic fundamental thing for any air-to-air missile combat. Now, beyond visual range air-to-air missiles are the ones which provide this capability. They are the ones which provide a capability to for the launching aircraft to detect its target at a long distance and thereafter launch the missile, and the missile will go certain distance and thereafter it will open its own eyes and ears and home on to the target. Okay. This is what is the latest state, but the story is not like this. It has evolved over last 3 to 4 decades. There was a time when the air-to-air missiles were beam riders. What is beam rider? An aircraft, 2 aircrafts are in combat. The aircraft which is to launch the missile illuminates its target with a beam, with a radar beam. And the missile rides that beam all the way through. It's called beam rider missile. Old Skynet missile of the US Navy was in this category. I'm talking of 50s and 60s technology when it is called a beam rider missile. After beam rider missile, what is the disadvantage? The enemy is also seeing that aircraft which is launching the missile because continuously illuminating. Electronically, he is visible to him. Okay. Second missile, after some time evolved, which is semi-active homing missile. What is semi-active homing? Here is the launching aircraft which is illuminating the target. The target is being illuminated. The reflected echo which is coming from the target is being picked up by this missile, and the missile is homing onto this. Still, own aircraft, launching aircraft is vulnerable because it is illuminating the target all the time, which is wave is getting reflected. Then came a combination of semi-active, active homing. What does that mean? It means that the radar illuminates the target for a certain time, launches the missile goes. After some time, the missile opens its own seeker and homes on to the target. The aircraft, launching aircraft switches off. This is the missile of AIM-7C missile is of this category of Raytheon. But today is a different scenario. Today the scenario is one of total net-centric warfare. What is this warfare? The aircraft today, 4th and 5th generation aircraft, are loaded with state-of-the-art aerial radars. Now, these radars detect the target. They are SR radars, active electronically scanned array radar. They detect the target at long ranges. And also, these ones that detect the target, the missile itself is not a dumb missile. The missile itself has got its inertial navigation system on board. It takes the input from the target, from the launching aircraft where the target is, and gets launched in that direction. And when it is flying to the target, it is continuously taking the update from the launching aircraft as to where the target is. And not only from the launching aircraft, it takes the update, it can take the update from what is called third-party sources. What is third-party sources? It can be a ground radar, it could be airborne radar, it could be a sea-based radar, it could be AWACS aircraft, it could be anything, and it homes onto the target and destroys it. So this is, what is this happening? At one time today, there is a scenario in which an aircraft does not have to open its radar at all to take on the target. He selects a target, and moment he selects the target, the situational awareness which is available to him, the common operating picture which is available to him because of the third-party resources starts to feed the inertial navigation system of the missile homes onto it and goes.
Okay.
Now the target, the radar in the missile is, they started with active radars. Now the technology has gone further. Not only active radar, they also have on board now infrared imaging radar. Means passive radars are also on board on the missile itself. And what is the third? One more capability is coming, is called distributed lethality. What is distributed lethality? The missile is going for a target, but it finds that there is a more lucrative target which is available to it at the point in time. It can have a secondary kill capability even on a ground target.
Okay.
So this is how the story has evolved, and the BVRAAM Meteor which you're talking about belongs to this INS active radar seeking capability.
Okay, so that's an evolution, and quite aptly summed up there by Lieutenant General Saxena out here. Let me bring AVM Srivastava. AVM Srivastava, now that we are talking about BVRAAM and its utility, its effectiveness, and the kind of BVRAAMs indigenously which we have developed, and the kinds which others have, which we are seeking as well, for example, Meteor. How do you see all these different kinds of BVRAAMs?
So, before I compare and contrast, let me add to the perspective. When we talk about the air power or the military power, the idea of air power or military power is to influence the actors or the course of events. That is what country wants.
Okay.
And for that, whatever missions you launch, they must be successful always. If they are successful always, they build up the deterrent which we need. Now we are talking about deterrent, and if there's a mathematical calculation which we talked about earlier too, that MOMS, if we take measure of mission success, it depends on two factors. One is mission attainment measure multiplied by survivability rate. So when we talk about BVR in that context, I am beyond visual range of my adversary. So he cannot hit me, but I can hit him. This is also part of the revolution in military affairs. And you add to this and couple with this the precision. When you do that, it becomes a very effective combat. That means you create a deterrent with leaner inventory within the confines of your budgetary constraints, and that can be more this thing. Coming back to our current status, we bought along with Rafales, we bought Meteor. Without Meteor, Rafale actually, despite its agility, it cannot have that kind of effectiveness and deterrent in tactical warfare. We are talking about tactical scenario, not strategic assets we are talking about. Now, this is a weapon which is today, Meteor today is top of the rack. If you compare with the Raytheon or compare with any one of the available ones, whether Python family or anyone, it is one of the best available today because of its almost stealth feature. It is considered to be stealthily launched because of its no escape kill zone, which is nearly 60 kilometers, which is very, very large. It can kill. If you are within that zone, you will be definitely killed because of its throttable, throttability of the engine, that it can race up or race down depending on how the target is behaving, and because of his very, very high turn in terms of G. So all that given, it is one of the top of the BVR missiles available today in the world. Coming back to Astra, Astra is again, I think for a first step, we have done extremely well. There's no doubt about it. We have done extremely well because it is one of the things which is in mid-range. Today we are talking about some range which is 110 kilometers for the heights we mentioned, but for a very maneuverable target also within 20 kilometers envelope, it is a no escape zone for the target.
Okay.
See, earlier what we used to have when there is a missile launched on us, as General pointed out, with the various earlier generation missiles, there was always a practice with the fighter pilots to have an anti-missile maneuver, and they could get rid of the missile which is launched at them. Or even kill the target aircraft which is launching the missile. The moment you kill the target aircraft which is launching the missile, then the missile engagement is gone. And another factor which we want for the current generation of missiles of BVR, it should be net centric, because the future wars are going to be net centric. You should be able to do mid course correction. You should be able to redesignate a target. As he rightly pointed out, if you find a more lucrative target which needs to be engaged, you should be able to do that. On all those parameters, Meteor really stands top of the rack.
Okay.
It's one of those missiles.
Okay. Manu, your views on the evolution, both the gentlemen have explained it very well, but how BVRAAMs are significant and how they've been utilized by other nations as well. Not many of them have it.
Yeah, it's a unique capability, and while some nations have it, they don't have the top of the end one. So Meteor, as pointed out earlier, is the best in the world. Remember where Meteor is made. It's made in France. You know, France is a country which has potential aircraft which are adversarial, can be both of Western origin, American and Russian. So it is designed for all types of aircraft. So that gives it an advantage of, you know, being more deadly than missiles of those particular countries. But more importantly, what does a BVRAAM like the Meteor give the Indian Air Force? See, we have entered a stage in which we don't want a loss of life. You know, whenever we want to do operations, we want to do an operations in a standoff distance. So we have seen this in Balakot. Our Mirage aircraft, which went in and struck the targets on the ground, they were at a standoff distance. They fired their air-to-ground missiles from about over 90 kilometers. Same here, yesterday we had, or day before yesterday, we had the shooting, we tried out a new artillery shell, the Excalibur on the M777, which can hit precisely a target at the range of 35 kilometers. It's an artillery shell. Meteor is the latest in that. So basically what this does, what this gives the Indian Air Force is the capability to target any aircraft within a range of 150 kilometers, which means theoretically if Pakistan was to scramble its fighter jets for an attack on India like they tried on Nowshera, this Meteor or two Rafales with the Meteor would strike them down. So this basically renders the Pakistani Air Force defenseless from a long distance. Now we had a mismatch here. We were not having this capability in the past, and thankfully with this acquisition and the very capable aircraft, we will have an advantage that from now on, whenever we are launching any operation on our borders, enemy aircraft won't bother us. Our pilots will remain safe. They won't be a target of opportunity for the enemy. And as we have seen, you know, air combat earlier used to be like, you know, the general pointed out, close range, used to have all those fancy maneuvers, you know, an aircraft pulling extra Gs and doing maneuvers to get out. But that's a thing of the past. Now engagements are at long range. That doesn't mean that close range is totally finished, because there might be a situation where you come close and don't fire, and the actual fighting happens at very close range. But BVRs have more or less finished off that concept. That's why we see that a lot of countries now are looking at this capability, and most companies also worldwide are investing heavily in this. And Astra is a good point and example, and I think what DRDO is doing is excellent. They are in fact planning to double the range. That's what the DRDO chief recently said. And if that happens, then if in a period of a decade we can gain that capability, which is you know, exceptionally good, we won't even have to depend on imports like the Meteor, which is actually a very expensive missile.
Okay. You spoke about Astra and the indigenous aspect, and even Srivastava also pointed out. Let me bring both the gentlemen again on the indigenous capability. You know, we have had indigenous capability in developing missiles like Agni and Akash as well. But having a BVRAAM for the first time and joining that elite club, one, how did we manage that? It has been almost 15 years of development, which has you know, resulted in developing this kind of missile. And what are its unique capabilities and characteristics? First you, General Saxena, and then AVM Srivastava.
Sir, I personally feel that while Meteor is the top of the line, as we have already brought out, but we have also done quite a lot of work and good work in that, and we must recognize our own indigenous capability, because tomorrow it is the indigenous capability which will hold you instead. Now, our BVRAAM capability development started sometime in 1990. And after about, let's say, 13-14 years of work, in 2003, the first BVRAAM called Astra 1 was launched. Now, what is this? What is the difference? What are you talking about? Now, if you talk of Meteor, it has got a throttable ducted ramjet. Means it can adjust its thrust in the missile combustion chamber, in which it can adjust what is the thrust developed by the engine, how much fuel is to be given to the engine. Like suppose if the target is a very far distance, then the missile need not burn out the complete rocket motor. It will burn out little less, and at the end game it will pump in more fuel in the missile system, so that it has a greater speed, it has greater maneuverability, it has a greater component in the end game, greater push and greater pull in the end game. That's why it has got such a tremendous no escape zone of 60 kilometers, in which the aircraft cannot outrun the missile. It cannot outrun means cannot make it expend its fuel completely. It can only outturn by maneuvering. Now our Astra 1 was not on this category. We did not have a ramjet earlier. We only had a rocket motor, and that rocket motor produced a thrust of 4.5 Mach, gave a range of 110 kilometers, and between 2003 to 2019, 29 times tests have been carried out of various Astra, and now we are coming out to Astra 2. When we talk of Astra 2, there were 3 types of development which took place. We also thought we will go in for ramjet technology. We thought, shall we go in for solid ducted ramjet, shall we go for liquid ducted ramjet, or shall we go for a dual pulsed motor, that means booster and sustainer thereafter. A decision was taken that will go for solid fuel ducted ramjet. What does that mean? It means that we will have a technology similar to Meteor, but even one better, means a different type of technology. What is this technology? In this, there will be a nozzle-free booster, which will boost the missile initially. The hot gases which come out, in the case of Meteor, when the hot gases come out from the booster, there is something called EPCU, Electronic Propulsion Control Unit, which has got a valve, and valve can throttle up and throttle down the engine depending on what thrust is required for the missile to go forward. In our case, we do not have this stopwatch system. Hot gases are coming out, we will have a hot gases regulation system. Means we will have a regulator which will limit the amount of hot gases getting into the combustion chamber. Thereafter, how much thrust is going to be produced. Similar way as Meteor, the Astra 2 is being worked on the same technology. If you will recall, February 2016, February 2019, the SDFR was successfully tested by the DRDO, that this technology called solid fuel ducted ramjet was tested. And now when the Astra 2 actually comes about, it will have a range of 160 kilometers. It will have a speed only of 2.3 to 4.3, 2.3 to 3.3 Mach. That is what is the speed which is being talked about. But what is more important? What is more important is that we are rubbing shoulders with the niche technology. Today we also have. Now what is the Meteor having? Meteor is having an active radar which takes care of the end game, that is the terminal game. Here our active radar will be an SR radar which has a range of 40 kilometers and will have a cone which will have a similar no escape zone, not so much as 60 kilometers, but will have a comparable. Like we talk of AIM 120D, it has an escape zone of 23 kilometers. This is a 3 times escape zone, but we will be somewhere in the middle. So we should be proud of the fact that our BVRAAM technology, which started in 1990, came to some stage in around 2003. Thereafter, continuously developing from liquid ramjet, decision taken to take solid fuel ducted ramjet, and developing hereafter. And in this testing process, the last test was carried out in 2019 February, which was a success. In fact, DRDO put out a headline that last 5 tests of Astra 2 were successful.
Have been successful.
So while you see what happens, the company, the Meteor company, the French have said very clearly that while we'll give you the Meteor for the Rafale platform, we are not going to integrate our Meteor with any of the Russian platform, with any of the Israeli platform. Now what happens to your Mirage 2000, what happens to your Su-30 MKI, what happens to your Tejas, which has got electronic warfare component from the Israeli company, what happens to MiG-29K, which is also requiring, you require your own weapon. And your own weapon is coming up in shape. We should respect that capability, we should utilize that capability, and we should stand by our capability.
Okay, and that is where the indigenous capability comes in handy. So, Avim Srivastava, 2 aspects here. One, our technology, which we have indigenously developed, is at par with what the best players in the world have in terms of BVRAAM technology. Actually, and second, it has come at the right time. We need it right now.
Actually, not only I'll agree with General on this aspect, I would rather feel it's a matter of pride for the country. But given all that, I must also say that improvement is an ongoing process. If today Meteor is the best in the world, we need to reach there. But if you really ask me, in motor technology, what General mentioned, we were always very good. We have been consistently good. That's why we have done all Agni series of launches, Prithvi series of launches, and Akash. All these missiles which have come about, they because of the rocket technology, and we have harnessed it very well, whether it is solid fuel or liquid fuel. Now coming forward, that we have made Astra throttable also. That means as far as this missile is concerned, we will be able to pace up or pace down depending upon how the target is behaving and what kind of agility the target is showing. That is another part of the game. But there is one thing we need to further master. Today if we see, the Astra has been built on two seekers. One seeker is Russian seeker, which is Agat seeker, which has come out, and the one is indigenous. So we have to still refine our indigenous Bell manufactured seeker, because seeker is the heart of the whole business. Now once that gets mastered, which I believe will get mastered, because as the order is being placed on BDL, we all know about it, and it's likely to come. The first order is going to be nearly of 200 missiles or so, out of which 100 with Agat seekers and next with Bell seekers if they succeed fully, which it will go. And I hope and pray that that happens, because that gives you the capability which you are really looking forward to. And once that capability comes and you are able to master that further, that's where, and another very crucial part comes with it. As Manu pointed out, this missile is very costly, Meteor. And if I compare with the cost of the missile which we are making, Astra, which is nearly comparable, because it's got all the features we need to improve upon, including the jamming resistant feature, which is very important. It can work in intense ECCM environment. I would say it is a shade down, but it is somewhere comparable. Then it becomes, price wise, it is 1/3. 1/3, that means I can acquire 3 times more. That's a very, very important aspect. And as General pointed out, I am free to put it on any kind of platform. MiG-29s, Su-30s, which are my mainstay. LCA at the moment I got Derby put on that, attached to it. I can do there also. So once I have my own technology, indigenous technology, and the industrial environment supporting that, then you'll really gallop into this technology. Okay. You'll catch up very fast. Catching up is not so difficult as producing the first working version. And the first set of things worked really well. They really worked very well. With the blast fragmentation being available, with the proximity fuse being available, the kill probability becomes very high. It does not blast before or very close to it. It goes only if the target is within its kill zone.
Okay.
So that's it. So it's a composite technology including seeker, blast fragmentation, engine, and the kind of guidance, mid-course correction, redesignation, all those factors will come in play to make a BVRAAM so effective as we want it to be on all our platforms.
Okay. Manu, with all these aspects, now that explained in detail about how our indigenous technology has come about and all that, and it is pretty much at par with the world's best out there, does save us money as well. And we obviously need to go ahead and, further build on our indigenous capabilities of developing BVRAAM technology. So if you look at it in a holistic perspective, where are we and where are we headed?
See, the problem that we've always faced, and this has been an issue which, a lot of people will agree, is that technology we develop, we fail in productionizing it, in manufacturing it. So I was fortunate enough to be in the French facility which makes the Meteor. I was there earlier this year, and they have been producing missiles there for 5 decades, and they've been producing hundreds of missiles a year. So their process of production is very precise. There is no fault. Our issue has been in the past, some very good products which have been developed by DRDO, once they get into production, they face issues and niggles. And that's when the armed forces reject them, saying the quality is poor, production is failing. So we have to improve on that. And the only way you improve on that is you have to place numbers. So if you place an order for 200, don't stop there. It's the first generation missile. You have to give the Indian manufacturer, I think you should call in private industry to manufacture this. They have more precise methods of production. But you have to just give them additional orders. You can't stop. We've seen an example with the Arjun tank. We did induct it in military numbers, but we should have had much more if we had to produce a next generation tank system. The same thing should not happen to a missile like this. We should be consistently ordering it, improving it, refining it while in service, and giving the Indian industry a chance to produce it at par with, say, what Western nations do.
Okay, and that gives what you're indicating is that gives the industry a chance to go ahead and put more effort into further research and development out there in terms of both resources and money as well, and obviously, motivation there. Jal Saxena, concluding comments from you.
My concluding comments are that technology doesn't stop anywhere. What is beyond BVRAAM? Now today, let me just tell to the user, today the stealthy aircrafts are coming.
Okay.
Now these aircraft do not require BVRAAM. They say we do not want such long range missile. We want more missiles of short range. Why? I can get closer to the enemy aircrafts or enemy targets without getting detected. I am stealthy aircraft. I require missiles with larger number but shorter range. This is called half a RAM.